Spartan fans, the chain rule part 1. Previously, when you were given a problem such as the f of x equals 2x plus 1 squared, it wasn't that bad. Multiply it out, and then you would find the derivative from there. So if we multiply this out, we would get 4x squared plus 4x plus 1, and we would say that dy dx, f prime of x, is equal to 8x plus 4. Okay, not so bad. Notice that if you use the power rule, we bring the 2 down in front, decrease the power by 1, so the 2 becomes a 1. And so notice that this is 4x plus 2. It is not 8x plus 4. So we're kind of short by a factor of 2. And where did that go? That's where our chain rule is going to come in. So what if I gave you something like, instead of 2x plus 1 squared, what if I gave you 2x plus 1 cubed? So let's just make a note here that these are not the same. What happened there? Okay, well, we could multiply out 2x plus 1, but it is certainly not a good use of our time. It's inefficient. So to help you out, I will already multiply it out. By the way, if you use the binomial theorem in Pascal's triangle, not something we use very often, but this is how you would multiply out 2x plus 1 cubed efficiently. So when you multiply this out, you would get 8x cubed plus 12x squared plus 6x plus 1. So just trust me on that. And we would say that the derivative from here, dy dx, f prime of x, using the power rule, would be 24x squared plus 24x plus 6. Okay, and then so we would multiply it out, we would find the derivative, but again, why on earth would we want to do that? Okay, I can write 2x plus 1 cubed as a composite function. So what does that look like when you write it as a composite function? So let's say y is equal to u cubed, and where u is 2x plus 1. This is a composite function, right? If you were to say that the f of x is equal to x cubed and the g of x is 2x plus 1, therefore the f of g of x would be 2x plus 1 quantity cubed. So this is a composite function. Let's find the derivative of y with respect to u. We're going to do this in 2 pieces. So let's find the derivative of y with respect to u. And that, I believe, is 3u squared by the power rule. And let's find here u. Let's find the derivative of u with respect to x. And I believe that's going to be 2 by the power rule. Well, if I multiply dy du times du dx, last I checked, that is dy dx. Reduce, please do not cancel. Cross reduce, you get dy dx. So we just found dy du. Dy du is 3u squared. Du dx is 2. Right? Well, I know u. We said u was 2x plus 1. So this is the same thing as 6 times 2x plus 1 squared, doing a substitution. This doesn't look the same. dy dx, we said was 24x squared plus 24x plus 6. But guess what? This is 6. 2x plus 1 squared, I believe, is 4x squared plus 4x plus 1. And that indeed is 24x squared plus 24x plus 6. And these do indeed match. Okay. So this is the chain rule. I'll give you a synopsis of what it looks like with proper notation in just a minute. Let's do another one that involves a trig function. Let's do another one involving a trig function. Okay, so let's say you're given y is equal to the sine of 7 minus 5x. You can't just say that the derivative of sine is cosine. This is not true. The reason it's not true is because 7 minus 5x is indeed a function itself. Let's rewrite it as a composite function. So let's say y is equal to the sine of u, where u is 7 minus 5x. This is a composite. F of x equals sine x, then you would substitute in. Okay, well, let's do that same process. Let's find the derivative of y with respect to u, and let's find the derivative of u with respect to x. My y function, I'm deriving u, and my u function, I'm going to derive with respect to x. And when you multiply these together, I think you will agree that this is dy dx. And I should put here y prime. Okay, well, the derivative of y with respect to u is the cosine of u. Derivative of sine is cosine. And the derivative of u with respect to x, I believe, is -5. Hopefully I didn't mess that up, but I'm pretty sure it's good. So dy dx, y prime, is equal to -5 times the cosine of u. But I know u is 7 minus 5x. So I can do a substitution here and say that this is -5 times the cosine of 7 minus 5x. And that is the derivative of sine 7 minus 5x. Okay, so let's look at a synopsis, and then we will do another example. You have some function that can be written as a composite. This is a composite function. The derivative of this take the derivative of the whole function multiplied by the derivative of the inside function. This is the chain rule. How about this? Dy dx of a composite function is equal to. This is sometimes referred to as the outside inside. This is sometimes referred to as the outside inside. Take the derivative of the outside function. So in this case, my outside function is sine. Multiply it by the derivative of the inside function, which is 7 minus 5x. So going back here, the outside function was 2x plus 1 cubed. The inside function was 2x plus 1. So let's go back actually and do that. The outside function, let me just rewrite this. So the outside is x cubed. So the derivative of that is 3x squared. The inside function is 2x plus 1, and the derivative of that is 2. So this looks like 6x squared when you multiply them together. Here's your 6. And your inside squared. It's 2x plus 1 squared. And then 2x plus 1 quantity squared is such. Multiply it out. So that is sometimes referred to, the chain rule is sometimes referred to as outside inside. Okay, they do get a lot more complex, obviously. Let's look at a product rule that involves a composite function. So let's say you have x cubed times the quantity 2x minus 5 to the 4th. How do you know that you need to use the chain rule? Because the quote unquote, what's being raised to the 4th power is a function in and of itself. X cubed doesn't require the chain rule. It's a monomial. No chain rule required. You got to be careful when you have binomials and trinomials, etc. Now, you could, if you wanted to, multiply this whole thing out and then find the derivative. Yeah, I don't think so. So this is my suggestion. X cubed is fine, right? The derivative of x cubed is 3x squared. Great, move on. Let's look at the 2x minus 5 to the 4th. I'm going to use this whole outside inside concept. I'm going to bring the 4 down in front. So let's just say that this is, we'll call it z for lack of a better, because I don't want to keep using the same variables. So z prime is, bring the 4 down in front. That's the outside. Multiply that now by the derivative of the inside, which is 2. This is 8 times the quantity 2x minus 5 cubed. The outside function is y to the 4th, whatever you want to call it. Brought the exponent down in front, made it a coefficient, decreased the exponent by 1, so 4 became a 3, and the 2 comes from the derivative of what's inside. Okay, now I'm going to use the product rule. So f prime of x, this is going to need some space. Hopefully I have enough, which I don't think I do, so I'm going to write it down here. This one's going to require a little bit of space. Okay. X cubed times the derivative of 2x minus 5 to the fourth, which we just figured out right here. So again, I'm just using the product rule. Plus 2x minus 5 to the fourth times the derivative of x cubed, which is 3x squared. This looks pretty nasty, and of course, there's no way I'm going to multiply this whole thing out. So this is 8x cubed, and we have a 2x minus 5, quantity 2x minus 5 cubed. That's a common factor, it's the GCF. So this is going to become, I'm going to take out a 2x minus 5 cubed. And that's going to leave me with 8x cubed plus 3x squared times 2x minus 5. All right, let's do a little bit of simplifying. So this is going to be, now from here, it's a bunch of algebra. But 2x minus 5 cubed. This is going to end up being, how about, let's see, 14x cubed minus 15x squared. Distribute, combine like terms. And of course, we have a GCF here. So let's take out an x squared. So we have x squared 2x minus 5 cubed times 14x minus 15. If you prefer to do the 2x minus 5 to the fourth using a derivative, a u substitution, you can certainly do that. And let me show you really quick what that would look like. So you could say y is equal to x to the fourth. You could say y is equal to x to the fourth, or let's do u, sorry. Where u is 2x minus 5. So dy du is equal to 4u cubed. Notice that's right here, 4u cubed. Du dx is equal to 2. Notice there's the 2. Multiply them together and you get 8u cubed. But u is 2x minus 5. So if you prefer to do the u substitution and find the individual derivatives and multiply them together, no problem. Next one we're going to do is pretty complex. So I'm going to go through it slowly and hope that I don't make a mistake because that would stink. Okay, let's look at y equals x over the square root of 1 plus x squared. So I find the quotient rule, I make a lot more mistakes when I use the quotient rule. So I'm going to rewrite this using the product rule and then go from there. Okay. So this is the same thing as y equals x times 1 plus x squared to the negative 1/2. All right, so dy dx, here we go. And you know what? I'm going to do the derivative of 1 plus x squared to the negative 1/2 off to the side. So the derivative of 1 plus x squared to the negative 1/2, let's just say that's u prime 1/2 down in front, or negative 1/2, I should say, down in front. Decrease the power by 1. Not done. Power rule. Exponent becomes coefficient, leave the inside alone. So I'm taking the derivative of the outside, subtract negative 1/2 minus 1 is negative 3/2 times the derivative of the inside, which is 2x. So u prime is going to be equal to negative 1/2 times 2x is negative x, I believe. And then that's x, 1 plus x squared to the negative 3/2. So, feel free to use the quotient rule, but I find that when I use the quotient rule, I always mess up the denominator with the subtraction. So you feel free. I'm going to use the product rule. It's going to be x times the derivative of 1 plus x squared to the negative 1/2, which we just found out here is negative x times 1 plus x squared to the negative 3/2. And wouldn't you know it, I didn't leave myself enough room. Gosh darn it. Plus the denominator, which is 1 plus x squared to the negative 1/2. Oh, can't believe I did this. Actually, I can believe I did this. Times 1. So let's simplify this a little bit. This is going to be negative x squared, 1 plus x squared to the negative 3/2. And then plus 1 plus x squared to the negative 1/2. All right, so these negative exponents, we're going to have to get a common denominator. So I just took care of, this should be plus, positive 1/2. Okay, so my common denominator is going to be 1 plus x squared to the 3/2. That's my common denominator. So this is going to be negative x squared. And then my denominator here is 1 plus x squared to the 3/2. There's no way you're not showing work for these problems, that's for sure. And then this needs to be, to get from 1 plus x squared to the 1/2 to 1 plus x squared to the 3/2, I need to multiply by 1 plus x squared. Because that's 2/2, add 1, you get 3/2. Okay, so negative x squared plus x squared is 0. The numerator is 1. So this is going to be 1 over 1 plus x squared to the 3/2. The derivative, I think the calculus part of this, finding the derivative, is the easy part. All this simplification is much harder. That's a 3. This should be 3/2. Still doesn't look like a 3. You might be confused about how I got here. The common denominator is 1 plus x squared to the 3/2. I only have 1/2. I need an entire 1 plus x squared in addition. So there we go. One more where we're going to have the chain rule twice. Do one more with the chain rule twice. Okay, let's take a look at the square root of the tangent of 5x. Let's first look at the tangent of 5x. So let's just say that z equals the tangent of 5x. So z prime, the derivative of tangent is secant squared. So this is your outside function. The tangent of x is this secant squared x, but now it's not x, it's 5x. So then this gets multiplied by 5. Okay, so that's the derivative of tangent 5x, but now we have to throw in the fact that it's the square root of the tangent of 5x. So dy dx. Maybe you want to think of it as the tangent of 5x to the 1/2, which is what you should do. So it's 1/2 the tangent of 5x to the negative 1/2 times the derivative of what's inside, and the derivative of what's inside is 5 secant squared 5x. So all in all, let's see, that's going to be 5. I don't want you to leave negative exponents. Don't be leaving negative exponents in your answer. So this is going to be 5 secant squared 5x all over 2 root tangent 5x. Okay. So you might be wondering, well, wait a second. We don't want roots in the denominator, so shouldn't I rationalize this? And the answer is probably, but this is pretty intense, so we're just going to leave it as is. So the chain rule, this is only part 1. The problems are clearly pretty intense, and we're going to do a lot more practice with them. So this is section 5, not 5, 6, section 3, 6, chain rule part 1.